that we can take out? No. Okay, so there's not a GCF. But ask yourself that question no matter what. Is there something in common that we can take out? So there's not. The second thing it tells us at the top is that we're going to factor by grouping, which is a part of the step that we use when we use the AC method. Does anybody know what you're supposed to do to factor by grouping? Holly?
Split the equation in half.
Yeah, split it in half. Perfect way of saying it. So we're going to split this in half. There we go. Put a little line down the middle. And then Holly, after you split it in half, what are you supposed to do with splitting it in half?
You would take out the first equation x squared.
So the first two pieces, she said take out an x squared. And then what's left in the middle?
X minus 2.
And then what about the next two pieces, the back two pieces?
Take out a negative 9.
Take out a negative 9, and in the parentheses is also
X minus 2.
x minus 2. So that's factor by grouping. Grouping means you're taking two parts of the problem and literally pairing them together. And generally, if you put a line down the middle, you're taking the GCF out of the first group, you're taking the GCF out of the second group. And then Holly, the last thing with factor by grouping.
You first two terms x squared minus 9.
Right, so you're taking the front terms, the terms that are in front of the parentheses, you're grouping them together. The reason we can do that is because the x minus 2 in the parentheses is the same. If that's not the same, then you cannot group them together and you did something wrong. But it is the same, so we can pull the x squared and the minus 9 together, and then the x minus 2. So that's factor by grouping. So the question says to factor by grouping, but then it also says to factor completely. So we've done the grouping part. We grouped the first two, grouped the second two. This is what we have as an answer. Is this answer factored completely? Holly? Why not?
You can break down x squared minus 9.
Right. This part here, the x squared minus 9, that's that binomial, perfect square binomial. And it can be broken down one further step. It can be factored. So they're both perfect squares. And Holly, how does that first pair there factor then?
X plus 3, x minus 3.
Right, x plus 3, x minus 3. And then the x minus 2 is as far as it can go because it doesn't have a higher power than just an x. So that's actually two different types of factoring. So this difference of two squares, perfect square binomial, whatever term you want to use, this can be factored as a pattern that we talked about in the last chapter as x plus 3 and x minus 2. And then the x minus 2 is already broken down. It can't be broken down any further. So this piece here would be our answer. It's factored completely. So when you're looking in the parentheses at the x, each x is by itself. It doesn't have a power with the x. Questions? So again, just working through some examples here. We'll work through these together. Factor completely. Those are going to be the directions that you now see. So it might not be just a one-step factoring problem, but we might need to use two different types of factoring to get the problem to break down. So we have x cubed plus 2x squared minus 25x minus 50. So if we look at this similarly like the last problem, when there are four pieces, four terms, try putting a little line down the middle and grouping the pairs together. Will, what could you take out of the first two pairs of that one?
X squared.
X squared. And we have x plus 2. How about the second pair?
Negative 25.
Negative 25. And then Will, what does that give you?
X squared minus 25 and x plus 2.
Good. So that's the factor by grouping. Is there anything else we'll do with that?
You have to take the x squared minus 25 and expand it.
Good. And that expands as,
X minus 25 and x plus 25.
what's the square root of 25? 5. Did you say 5?
Oh,
I think you meant 5. So we have x minus 5, x plus 5, and then x plus 2. Questions? So number 2 is different from 1 and 3 on here. Number 2 is a trinomial. So a trinomial is 3 pieces. But it has an x to the 4th instead of having x squared. We're used to factoring with x squared, ax squared plus bx plus c. So this is now x to the 4th, and then 14x squared, and then plus 45. Anybody have a suggestion about how you'd start factoring that? Julia?
Find what to factor in 45.
Yeah, so any trinomial, those 3 terms make a trinomial. When it's in standard form, we're going to try and use that traditional factoring, AC grouping. So she said find the values that multiply to be 45. What values multiply to be 45 but combine to be negative 14? Negative 9 and negative 5. So this is standard factoring that we did last chapter, except we're just tweaking the powers a little bit. We've got an x to the 4th. All right, so factor by grouping, or AC grouping, says we start with the x to the 4th, and then we're writing our next part here. So the next step would be to take these factors and replace negative 14x squared with those 2 factors. So we have a negative 9, but instead of writing 9x, it's an x squared because it's 14x squared. We're changing the way that middle term is written. So if that middle term has an x squared with it, we have to write our factors with an x squared. And then negative 5x squared, and then the plus 45. So the only difference in this problem is the powers. The powers are changing on us because it's no longer x squared and x, but it's x to the 4th and x squared. So just like the other problems now, we have these 4 pieces. Put a bar down the middle. Abby, what would you take out of the first 2 terms in the front of that bar?
X squared.
X squared. And then in parentheses we would have,
X squared minus 9.
right, x squared minus 9. So just be careful because now the powers are larger. When you take out an x squared, you had x to the 4th. So when you take out x squared, you still have x squared inside. Abby, how about the second pair?
Negative 5. And it's x squared minus 9.
Okay. So she said negative 5, and then it's x squared minus 9. And then what, Abby?
And then you group them together. And it's x squared minus 5 times x squared minus 9.
Nice job. All right, so we've done the AC grouping method. That's what that's called. A times C, you're multiplying the first number and the last number, and then you're grouping. So we call that AC grouping. When you look at this answer, you need to ask yourself, is it completely factored, or is there a parenthesis that can be broken down further? So Abby, is it completely factored, or is there a parenthesis that can be broken down further?
You can break the x squared minus 9 down to x squared. And x plus 3 is minus 3.
Right. The 9 is a perfect square. We can take the square root of 9. And that can be broken down as x plus 3 and x minus 3. 3 times 3 makes 9. It's a perfect square. 5 is not a perfect square. Square root of 5 is a decimal. We want to keep that as a whole. So we have x squared minus 5 and then x plus 3x minus 3. So if your answer in parentheses is still a perfect square, then we want to make sure you're breaking that part down. Questions? See if you can do the last problem on this page, and then we have a couple other factoring problems to look at on the next page. I think this is the last one for this page. So 4 terms, 4 pieces means place a bar Jewel, what'd you take out of the first pair? And then that left you with?
X minus 1.
And the second pair?
-1.
Also leaving you with?
X minus
So pulling the terms in front together. And then it can be factored any further.
1. The first one, x squared minus 4, and then the x plus 2, x minus 2.
Nice. And then we have x minus 1. Questions? So if you flip the page, there are just some more factoring problems at the top there. And then I think there's one solving problem as well. So this says day 2, but it kind of just continues on with the examples. So again, factoring completely. Those will be the directions that we have to work with. These powers are pretty large. We have 16x to the 4th minus 256. And then for b, we have 3y to the 7th. So our powers are pretty large. Before you start thinking about factoring it with a certain method, is there a GCF that we can take out? So first question, GCF. Can we take out a GCF, Abby?
You can take out 16.
Yeah, we can take out a 16. Both of these are divisible by 16. So we'll pull the 16 out, and then we still have x to the 4th. Abby, what is 256 divided by 16?
16.
16. So first step, take out a GCF. They have something in common, pull out, they have in common. The next step, we need to look at the parentheses and try and decide, is that one of the patterns we've used, or is it a type of factoring that we've used to break it down any further? Does anybody have an idea as to how to try and get that to factor x to the 4th minus 16? Huh? Okay, so what was that word again?
You could,
How about we try the square root?
yes.
Okay, so let's try the square root. So both of these are perfect squares. Let's see if we can take the square root of it. So Holly, if we have x to the 4th, what times what makes x to the 4th? What two powers of x would we multiply together? X squared. So the square root of x to the 4th is x squared. So this is that pattern. It's a binomial. They're perfect squares. Even though it says x to the 4th, the square root of x to the 4th is x squared. Because when I multiply x squared times x squared, we get x to the 4th. Holly, what's the square root of 16? 4. So one gets a plus sign, the other one gets a minus sign. That's the pattern of the difference of two squares, a perfect square binomial. I'm going to put a 16 in front here. So they're perfect squares. We can take the square root of them to factor it. After you do that, you have to look at your answer and ask yourself, is it completely factored, or can one or maybe both of those parentheses be factored further? Mackenzie Myers, is it completely factored, or can one or both of them be factored further?
The first one can be
Why do you say the first one?
because the other one, if you use a negative 4, can't be a square.
But this was a negative right here. So she says maybe both of them. She's feeling like possibly both of them. Anybody else have an idea? Melanie?
Could you make it x plus 2 and x minus 2?
Which one?
Both of them?
Let's start with the one in the back. Okay, so let's start with the last one. She said x plus 2 and x minus 2 for the last one. Because these are both perfect squares. It's a difference of a binomial. So it's a binomial perfect square, but that's a difference. Let's talk about the one in the front. Just just gonna write it over here. You don't have to write this, I just wanna talk about it. If we factor this, there's a plus sign here. If we factor that as x plus 2 times x plus 2, what does that make? If you FOIL that? Melanie, what does that make if you FOIL it?
X squared plus 4x plus 4.
So this can't factor like that because it doesn't give us the same answer. So that's not an option. Melanie, I'm going to pick on you again. What if we factor it as x minus 2, x minus 2?
You get negative 4x plus 4.
And that's not the answer. So that's also not an option. Can x squared plus 4 be factored? No. So it has to be a difference, it has to be a minus sign, because when you FOIL the sum and the difference together, that's how you get those two pieces to cancel out. If I FOIL this, I would get x squared plus 2x, but then we'd have a minus 2x and the minus 4. The middle terms cancel, and that's how we get x squared minus 4, because those middle two terms are canceling out. But when it's a plus sign, there's no way to get those middle two terms to cancel. So this is not factorable. It has to be a minus sign, not a plus sign. So the back equation factors this part here, but the front one just stays as x squared plus 4. So it cannot factor because when you try and factor it, the terms in the middle don't cancel, they stay there. So it is not factorable. So the final answer, the 16 was the GCF. X squared plus 4, yes, it's a binomial, but it's a sum, not a difference. So it cannot factor. And then x plus 2 and x minus 2. So looking at letter B, asking yourself the same first question, is there a GCF? 3y to the 7th, 15y to the 5th, 18y cubed. Fran, what do you think? Is there a GCF?
3y to the third.
3y to the 3rd. And when you take that out, what do you have left?
1, 5y to the second, and 6.
And then just 6. So taking out a 3y cubed, we have y to the 4th. Subtracting your powers, 7 minus 3 leaves us with 4. Negative 15, subtracting the powers, there were 5, taking away 3 leaves us 2. And then we have the plus 6 because there were y cubed, but we took the y cubed out. Okay, so first up, GCF. What do you do next then? Julian, what do you think?
We can try and factor the stuff inside.
Yeah, try and factor the stuff inside. Trinomial, 3 pieces, means let's try and take A times C. So that gives us a 6. Julian, are there any numbers that multiply to be 6 that combine to be negative 5?
Negative 2,
Negative 2, -3. So this is AC, we multiplied A times C, and now we're going to try and group it. So we're going to rewrite it first. Y to the 4th minus 2y squared. Don't forget the powers are now changing. Really look at your powers that you have. And then there's a negative 3. It gets a y squared because this was a negative 5y squared. When you're rewriting it, it should be equivalent. We're just changing the way it's written. And then there's a plus 6. Julian, if we group the first two together, what would you take out of y to the 4th minus 2y squared?
you can take out y squared.
And then that leaves us with,
Y squared minus 2.
nice. And then the second pair,
Take out negative 3.
and that also leaves us with,
Y squared minus 3.
nice job. So pulling y squared and minus 3, they're grouped now. Y squared and minus 2 also grouped. And then Bram told us to take a GCF out. Don't forget about that GCF. It's part of our answer, 3y cubed. 3y cubed, y squared minus 3, y squared minus 2. Can these be factored? Are they perfect squares? Can you take the square root of 3? Can you take the square root of 2? No. So, yes, they look like they're in that form, but you can take the square root of 4, the square root of 3 doesn't work. It's not a nice number. It's 1.7 something. The square root of 2 is 1.4 or 1. Questions? So I believe there's one other problem underneath here, and I think then you got a word problem. So we'll look at this problem here, and we'll maybe talk a little bit about a word problem. It says, what are the real number solutions of the equation x to the 4th plus 9 equals 10x squared? Well, I guess there's a problem underneath too. But we'll look at this one here. So real solutions. That means we want to find answers. A solution means solve for x. X to the 4th plus 9 equals 10x squared. Just going to rewrite it. So we've done all this factoring. Haven't really talked about solving in a little while. How do you find x? We want a solution. We have to find x. What do you think you'd need to do to find x? Abby?
Get it by itself.
Okay, so she said get it by itself. How would we try and get it by itself? What do you think would be the first thing we'd have to do here? Julia? So take 10x squared to the other side. Writing it in order, we have x to the 4th, negative 10x squared plus 9. But we didn't really get it by itself yet. But that's our goal, to get x by itself. In order to get x by itself, Julia, what were you going to have to do with this to get x by itself? Right, we're going to have to factor it. So we have to set it equal to 0 so that it can be factored so that we can get x by itself. So working through this, it's now that trinomial form. So Julia, we have a 9, two numbers that multiply to be 9 combined to be negative 10. And then rewriting it, remember it's a squared in the middle. So taking the two factors, writing them with x squared, and then pulling out what they have in common. So Odette, what would the first pair have in common? And that leaves you with, in parentheses, and then the second pair, also leaving you with, nice. So this is x squared minus 9, and x squared minus 1. Can they be factored further? Hey, we can take the square root of 9, x plus 3, x minus 3. How about the next one? Yeah, you can take the square root of 1. 1 times 1 makes 1. X plus 1, x minus 1. So Abby said we need to get x by itself. X is now in 4 separate parentheses. Each of those x's are by itself. So we have 4 answers because each of those parentheses gives us a different answer for x. So if you solve for the first one, you get a negative 3. The second one is a positive 3. And then we have a negative 1 and a positive 1. When you look at the power of the problem that you start with, so if I go back to the top here, we started with x to the 4th. That power tells you how many answers you should have, because there are really 4 x solutions because my power is x to the 4th. So the power was x squared in chapter 4. We always had 2 answers for x. X to the 4th means that we should have 4 answers for x. And there's our 4 answers. Questions? Alright, so I'm going to go down to the word problem. We haven't done I think I skipped the word problem in the last 2 sections, so we'll try not to skip this one. My diagram, I think, looks a little nicer than yours because mine has a little bit of color and yours is a black and white. It doesn't copy as nicely. But you're designing a marble basin that'll hold a fountain in a park. So think of this as a bathtub, a nice brick bathtub. We talked about soap yesterday, so here's our bathtub, so we can use some soap. The basin, or our bathtub, has the sides and the bottom being a foot thick. So this is essentially, like, if any of you have like flowers in your yard, this is like a flower pot, but it's rectangular instead of being nice and round. It says the outer width should be twice, its outer length should be twice its outer width and outer height. So they give you the diagram, everything's labeled. So here's the width. We have the 2x, so the length is 2x. Its width is 1, its height is 1. And then the thickness, because this is supposed to hold water, it has to have some kind of thickness. So if this is cement, it has this 1 foot thick rim kind of going around it. So we want to fill the inside so that it can hold 36 cubic feet of water. I know that's kind of a lot to think about. But let's talk about if something is being filled. If I want to fill the space inside, what formula would we be trying to use if I want to fill the space inside? Jillian? Volume. So we want to talk about volume. We don't want area, because now we're going to fill this space with volume, with water. Jillian, if you have a rectangular prism here, what would the volume be? Do you remember how to find volume? Right, length, width, and height. And it says we want this wonderful fountain to hold 36 cubic feet of water. That's the volume. All the water going in, 36 cubic feet. So it's telling us that our length is 2x. However, that 2x is the entire thing. Our water is going on the inside. So think of your bathtub. When you step in your bathtub, or your shower, it has that border around it. That border takes away the space that you can fill in the water on the inside. So if my whole length is 2x, I have to eliminate the space on each side. Because the inside space isn't 2x, the whole outside space is 2x. And that space that we're eliminating is 1 foot on each side because I have this 1 foot border to create the planter, or to create, in this case, the fountain. So we have to subtract 2. The whole thing is 2x, but I need to subtract the 1 foot on each side because the distance inside is not the same as the distance on the outside. So we're subtracting 2 feet because I have a 2 foot thick basin on each side. So then the width, it says, is x. But again, I have this border going around it. And it's a 1 foot thick border so that the water stays inside and it doesn't go out. And it has to be thick so that it can contain and hold all this water. So we also have to subtract 2 from the length and 2 from the width. So we have our length, we have our width, and then we need to talk about the height. The height is also x. But it says the basin's side and bottom should be 1 foot thick. So it's not sitting on the ground, because if it was, the water would spill out of it. It has a bottom to it that's a foot thick. Does it have a top to it that's a foot thick? No. So instead of subtracting 2 from the height, we'd only subtract 1. So we're subtracting 2 from the length because it has 2 sides. So one side has a foot, the other side has a foot, so that the space inside is not as long as the space outside. Same thing with the width, and then the same thing with the height. So kind of just talk about what would you do to solve this problem. We've now set it up. What would you have to do to solve it? What's one thing? Because there's going to be multiple steps. What's one thing we'd have to do to solve this? after we set up the equation? Connor?
Foil to the equation.
So FOIL multiply this side here. So we'd have to FOIL it, multiply those together. Connor, what's another thing after you do the FOILing and multiplying you think you'd have to do?
Multiply to 2x minus 2.
Okay, so multiply the 2x minus 2. But if we did all the multiplying over here, what else would we have to do after it's done being multiplied? So you've done all the multiplying. What would the next thing be after you've done the multiplying? What would the equation have to be equal to? Abby?
0.
Right. So we would FOIL multiply all of this stuff together. And then we'd have to set it equal to 0. So we set up the problem. You're going to FOIL multiply. You're then going to set it equal to 0. And then the last step would be to factor. So it's actually a pretty involved problem. Because you have to kind of think, how does it get set up? And then you have to FOIL. And then we have to set it equal to 0. And then we're going to factor it. So you're FOILing it to get it equal to 0 to kind of go back and factor it. So I'm going to stop there. I have 5 minutes. What questions do you have remaining from your homework? That you would like to talk about? So I'm going to walk around and check your homework. If you have questions as I come around, please stop me. So if you could just keep your homework out, place it on the corner of your desk, I'll be around to check it. Ask if you still have questions. On this worksheet, I'd like you to do 1 through 28. And then I'd like you to set up number 30. So see if you can get it set up with the equation. The answers are on the back. Please do this on a separate piece of paper. These require some work. If I can get around to the